Welcome back to Learn by Making. Today we're going to model a pivot joint, a two-hole pivot joint. It's part number 14011 on 8020.net. We're going to model most of it. I won't model the bearings, but other than that it'll be the same. So I'll put a hole in the middle, as you can see here, where you could just put a bolt through it. So stick around and we'll get right to it. Okay, so before we can start modeling this pivot joint, we need to understand what it is we're modeling. So if you go over to 8020.net, you'll find this blueprint for the part. And the first thing I noticed is that this whole assembly is made up of two of the identical pieces, same identical pieces. So we'll just be modeling the one, and then I'll show you how to use an assembly workbench to create the entire pivot joint. The other thing to notice is that there's a lot of dimensions. If you go to the bottom of the page that has this blueprint, you'll see these dimensions listed in a table, and those will be helpful. But one thing that's kind of jumped out at me is that there's things here that you don't really know. So this blueprint doesn't tell you how tall this piece is. I'll call this the base, or the block. I'll just call it the base. Doesn't tell you what the thickness of this base. It also doesn't tell you how much clearance is between the bottom of the base and the bottom of the arm. I'll call this the arm. So it doesn't tell you what this gap is. So there are things that it doesn't tell you, and there's a lot of duplicate information too. Like E and A are the same, and D and B are the same. So the blueprint might look complex or might look complete, but it really isn't. So obviously this blueprint is not designed to help you design this thing from scratch to match the exact real thing. It's probably mostly there to give you a sense of whether you could actually use this pivot joint in whatever it is you're building. So we'll make some guesses and some infer some values. But we'll come up with something that's pretty close to this. So go over to 8020.net, take a look at this information, take a look at the dimensions, and just get a good feel for what this thing looks like before you start modeling, so you can kind of know what approach you're gonna take. So with that, we'll fire up FreeCAD here and start creating this thing. I'm going to start by modeling what I'm calling the base. That's kind of this block thing here. I'm actually going to start by creating a spreadsheet to hold all the values, just in case we want to change it later. So we go to the spreadsheet workbench and create a new spreadsheet. And then some of the values I'm going to need. So looking from the outside of the hinge, the outside of the pivot joint to the inside, there's kind of this narrower face of the base, and I'm going to call that the outer face. And then there's the wider one, which I'm going to call the inner face. So we'll just call this base outer face width and base inner face width. So I know I'm going to need those two things. These also have fillets on them, so I'm going to need fillet radius. These two look the same. The fillet radius on the outer face and the fillet radius on the inner face look to be the same to me. So I'm just going to call this the base fillet radius. Okay, so I'm just going to guess 2 millimeters. The outer face width, which is the narrower one, is, let's see, that's J, so that's 25 millimeters. And the interface width is A, which is 28 millimeters. And then we need to give these some aliases, and I'm also going to add the display units in here. So these are millimeters. We'll call this the base outer face width. And then same thing on here. Okay, so with those in mind, let's create a new sketch. So we'll go back to the part design workbench and create a sketch. I'm going to do this from the top down. That just seems most natural to me. All right, so let's start by sketching or drawing the base interface. That's the wider one. So we'll just do a square and we'll center it about the origin with a symmetry constraint. And these two sides are equal. And let's do this might end up being a problem. So let's put in the fillets for now. So we're gonna probably lose our symmetry constraint. We'll need to reapply that. So in this case, we're gonna make this point symmetric about the origin, and this point symmetric about the origin. Let me actually grab the points here. There we go. And we have some redundant constraints, so the vertical constraint is redundant, and there we're good. Now we'll make these four fillets the same radius. So we'll make those equal. Okay. And then let's set actually start putting in some values for these. So we're going to do the radius constraint on this, and we're going to refer to our spreadsheet. That's the base fillet radius. All right, and now we can set the width of this thing as well. And that's the base interface width. Okay, so that sketch is fully constrained. And as usual, I like to name things so that they're easy to figure out what's going on and what's what. So I'm going to call this the base interface sketch. And let's create another one, also from the top down. This is going to be the base outer face. So that's this one here, the narrower one. So it's going to be pretty much the same thing, just with different dimensions. Okay, so I've actually not done this quite correctly here. What I need to do, so I've set this as 25 millimeters, but that's not correct. The width is actually of the whole thing. So let's delete that and do it here. And then we'll close that, and let's go back to this one because I've made the same mistake there. So let's delete that and then set the constraint on those 2 points. Okay, that's more like it. Let's rename this one. That's the base outer face sketch. And then we need to move this up. What we're going for here is we're going to extrude from one sketch to the other. So we need to move this outer face out a little bit, or up a little bit. So I believe that's in the attachment. Yeah, attachment. All right, so I need to move that in the Z direction, the Z axis. But I don't know how much. Remember I said how this thickness is not defined. So I'm going to add an entry to the spreadsheet. I'll just call it base thickness. And I'm just going to make a guess for now, and then we can come back and revisit it. Okay, that seems reasonable for now. Okay, and then the last thing we want to do here is extrude this, or sorry, loft it. I believe that's what we want. Yes. So let's loft that. And that seems good. All right, and there we go. Might be a little on the thin side, but we'll make adjustments later. But as you can see, we have basically our base, and that looks just kind of like the blueprint there. So let's save it. I like to save a lot, and let's rename this to base. Okay, and then the last thing I'm going to do here is I'm going to change the color of this because bright pink is not working for me. So let's change the appearance. I'll change the color to, say, I don't know, gold. How about gold? That works a little better. And then I like to look at it from perspective view. Okay, so there's the base. Next we will work on these little tabs that kind of poke out from the top of the base. So we'll do that next. Okay, so we have the start of our base. I'm going to add some tabs and a hole to this. So to do that, I'm going to draw on a datum plane. You should probably look up something called the topological naming problem, and I'll link to it in the description below. And I need to go through this too. I just heard about this, so the recommendation I've seen is to draw on datum planes instead of directly on surfaces of other objects. So that if you change those objects, it won't break the names of the internal names of the objects that depend on it. So I'll create a datum plane, and I'll put it on I believe the plane face, and then if you look, it's too low. I want it actually at the surface. So at the top of the what are we calling it? We're calling that the outside face. So I'll just change the, change the placement, I believe. Yeah, so I'm gonna make that the thickness of the base. So we'll just do spreadsheet dot base thickness. And now we can see we have a plane that no matter what the thickness is, the plane will always be at the top of the base. So we'll go OK. And then on that datum plane, I will create a sketch. So let's do the hole. So we'll just do a circle centered at the origin. In my spreadsheet, I've added this base hole diameter, and that is based on value C in the blueprint, and that's 6.6 millimeters. So I'm going to constrain the diameter to that value. Okay, so close that, and then we will pocket that. And let's try doing this based on the thickness of the, we could do through all, but I want to try doing this on the spreadsheet base thickness. And we'll see if that actually, yeah, that does give us a hole through everything. So we'll do that. Let's name some things here. So this is the base hole datum plane. And then this is the base hole sketch. And the base hole pocket. Actually, just the base hole. We'll just call that the base hole. All right, so next, let's hide this datum plane just so we don't have to look at it. And then I want to create another sketch for the tabs. So we'll create a new datum plane for that. We'll put it on the plane face. And then same as the previous one, we'll place that above in the z-axis direction the thickness of the base. And we'll draw a sketch. Alright, so these tabs, they're basically just little rectangles. So I'll just draw a little rectangle there. Now, I'm going to make, let's see, we want this kind of on the edge. So we're going to set, well, first let's make it symmetric about this axis. And get rid of the vertical constraint. Okay, now let's put this on the edge by doing a horizontal distance constraint. And that is here. That's based on the spreadsheet. And that's base, this is the outer face width divided by 2. And that should put that on the edge. That's good. Now this we want in our spreadsheet. We want to add some things for the tabs. So let's see, tab height. Tab height on our drawing. Let's see. Tab height on our drawing is this. It's G. Down here it says 2 millimeters. So we'll go 2 millimeters. Okay, we also want tab thickness. And the tab thickness is here, H. And H is 1 millimeter. All right, and then we want the length of the tab as well. So tab length, and that is right here, M, and M is 6 millimeters. And with those things, we should be able to size this properly. So this one is the tab thickness. Okay, 1 millimeter. And this one is the tab length. So we'll do vertical constraint. Okay, and our sketch is fully constrained. So now we can close this, and we want to pad it. And we want to pad it the thickness, so the tab thickness from our spreadsheet. Sorry, not the thickness, the tab height. That's what we want. Okay, let's hide this datum plane. So we've got a tab here, so that looks good. Let's rename these things just so we don't get out of control here. I did not mean to do that. Okay, so that's the tab datum plane. And that is the tab sketch. And that is the tab. Okay, the next thing we want to do is replicate this. We want 4 of these. So I am going to do a polar pattern for the tab. And 360 degrees, we want 4 of them. All right, so that looks good. Just rename that. Do the tab polar pattern. And we'll save it. Okay, so we've done our base. This video is getting kind of long, so I think I'm going to split this up into multiple parts. This is part 1. In part 2, I'll start working on the arms to create these 2 arms that have the hole through it for the bolt. So go ahead and check that out, and we'll see you in the next one.